Determine whether the following series converges or diverges. If it converges, find its sum. On first glance, you might think that this is telescoping just because you see this minus sign, but that doesn't work out. Your first thought actually should be to try to take the limit of the terms, because if the limit of the terms is not 0, then you know for sure that the series will diverge. Now usually you want to be able to do this quickly, because if it ends up that you spend a lot of time on it and it's equal to 0, you're left with nothing. If the limit is 0, the test is actually inconclusive. What we're using here is called the test for divergence. Some might call it the nth term test. And so let's consider that limit. N gets big, so the first term gets big. But the second term also gets big. Infinity, a large number squared minus another minus that same large number will still be large. You take the root, it'll end up still being large. And so we have infinity minus infinity, which is an indeterminate form. So we must have some kind of algebra or something to do with this to make it so that we can find out what this limit is. And the algebra that would come to mind would be to multiply by the conjugate. If you have a minus root b, the conjugate is a plus root b. You bring that in with the goal in mind of when you multiply this out, you get a, the minus a root b and the plus a root b from the o and I FOIL terms cancel, and you get minus b. You end up basically, a squared minus b. You end up basically losing your root. That's what we're going to do. The conjugate would be n plus the root of n squared over n squared minus n. So we multiply by the conjugate, but you can't just multiply by it. It needs to be such that you multiply by it over itself. Multiply by 1. When we FOIL this out, we get the n squared. That would be like the a squared. Now be careful with this other part though. The middle terms definitely cancel, but when we multiply the two root b's times each other, it's minus the entire inside, because it's a negative times a positive. So you have to introduce parentheses in, because the minus applies to both parts. The denominator just be the conjugate, and we get some cancellation. The two n squared terms cancel out, and we're left with an n. And so we have this n over n plus root of n squared minus n. And we like to know what happens as n gets big. You can try L'Hopital's rule. It definitely is infinity over infinity, but you end up in some infinite loop somewhere you can't get out of, and so that's not the way to go either. I'm not a big fan of the hand wavy way of answering it, where we say, oh, let's just drop minus n as n gets big, and root of n squared is like an n, and n over n plus n is like n over 2n, and so just that whole argument is just not the way to go. We have to show this algebraically. And so what we're going to do then is to go to the next slide and figure out how this is going to simplify. So we're trying to take the limit of the a sub n terms, and we're at this point here, and what we're going to do is algebraically simplify it by focusing on the denominator. In the denominator we have an n and a root of n squared minus n. The highest degree term in the denominator might look like an n squared, but that's underneath a root. So actually the highest degree term in the denominator is n. And what we're going to do is multiply the numerator and denominator by the reciprocal of that term. The purpose of this is to force the denominator to go to a constant, and then see what happens with the numerator. So we're going to multiply by 1 over n, both numerator and denominator. Okay, so when we do that, well, the n times 1 over n becomes a 1, and it happens again here, but when we do the root times 1 over n, doesn't really work out too well. Let's just look at it. We can't get in there and cancel without having a root on that n. So we're going to cleverly rename n. We're going to rename it to be the root of n squared, so that we can then incorporate it with the other root. So this limit then will become 1 plus 1 over the root of n squared minus n divided by the root of n squared, with the goal in mind to make these underneath one root. So we have the root of n squared minus n divided by the root of n squared. So we put it underneath one root. And now what we want to do is combine these, or actually they're combined. We want to split them up. We're going to have n squared over n squared minus n over n squared. That's just going to be 1 minus 1 over n. So let's go to the next slide and just flesh that out. So we have 1 minus 1 over n. We have n squared over n squared minus n over n squared underneath a radical, and that's 1 minus 1 over n underneath a radical. The purpose behind this method also is to get yourself a bunch of terms that you're going to know go to 0. Anytime you have a constant over n to some power, as n gets big, as long as p is some positive power, that's going to go to 0, and k is constant. And so we have 1 over n, that definitely goes to 0. And we'll be looking at 1 over 1 plus the square root of 1, or 1 over 1 plus 1. So we're done. We found the limit to be a half. So what do? We took the limit of the a sub n terms and we got a half. The point is that a half is not 0. So ultimately then, since the terms don't go to 0, you are sure then that the series will diverge. And thus we just state it like that. And what we're using here is called the test for divergence.